Alright, so what I want to go over today is a trigonometry problem. It is as follows: the sine of 4 theta minus the sine of 2 theta equals 0. So the first thing we want to do is we want to use a trigonometric identity to transform this into something that we can actually solve. So we're going to use the following identity, which says the sine of u minus the sine of v equals 2 times the cosine of u plus v over 2, and then that's multiplied by the sine of u minus v over 2. So how this identity looks when it's applied to the problem we're trying to solve, which is above, is going to be 2 times the cosine, and then you have u plus v. In this case, u is going to be 4 theta, and then v is going to be 2 theta. So 4 theta plus 2 theta divided by 2, and then you multiply that times the sine of u minus v, so 4 theta minus 2 theta over 2. So that equals 0. So now what we want to do is we want to simplify this part right here. So you have 2 times the cosine, 4 theta plus 2 theta is 6 theta over 2 times the sine of 4 theta minus 2 theta, which is 2 theta over 2, equals 0. You have 2 cosine of 3 theta. 6 theta divided by 2 is 3 theta times the sine of theta, because 2 theta divided by 2 is just theta, equals 0. Now you can divide both sides by 2 to get rid of that 2 on the left hand side. So then it looks like the cosine of 3 theta times the sine of theta equals 0. Because when we divide this by 2, that cancels out with that, and then 0 divided by 2 is just 0. So now we have the cosine of 3 theta times the sine of theta equals 0. So we can break this into two separate parts. So this is going to be true when the cosine of 3 theta equals 0, or when the sine of theta equals 0. So you have these two equations right here, and when either of them equals 0, that means this whole entire thing is going to be equal to 0, and that's what we're trying to solve for. So we have these two separate equations, and now we can just solve them. So we're starting off with the easy part. So sine of theta equals to 0. So you'll learn this in your trigonometry class, but if you have a unit circle, so it looks like this. The sine of theta, and theta is just a measure of the angle in degrees, it equals 0 at this point right here, which is actually 0. And then if you go all the way around this circle, it also equals 0 at 2 pi. So you have theta equals 0 in 2 pi, which solves this equation. So anytime you plug in the sine of 0 or the sine of 2 pi, you're going to get 0. So that solves that equation. Now we got to figure out where the cosine of 3 theta equals 0. And what we're trying to do is we're trying to solve for theta and see where theta equals 0. So how you can do this is you can just take the inverse of the cosine function of both sides. So you do the cos, the arc cosine, or the inverse of the cosine, and you do that to both sides because you want to get theta by itself. So this cancels out and that cancels out, so you have 3 theta equals, and then you have the cos, that's supposed to be 0. So what this is saying is, where in the unit circle does the cosine equal 0? Well, it equals 0 right here, and that is pi over 2. And then it also equals it here, which is 3 pi over 2. So you can set it up as 3 times theta equals pi over 2. And then you have 3 times theta equals 3 pi over 2. Okay, so now you just saw both of these equations for theta. So I could divide this side by 3, divide that side by 3. That cancels out. Theta equals pi over 6 is one answer. And then you saw this one for theta. Divide by 3, divide by 3. That cancels out, that cancels out. So you have theta equals 3 pi over 6. And that simplifies. So theta equals pi over 2. 3 over 6 is just 1/2. So that's another solution. So now what we want to do is we want to write down all the solutions we have. So going back to what we're trying to solve, we have the cosine of 3 theta times the sine of theta equals 0. So that equals 0 when the cosine of 3 theta equals 0 or the sine of theta equals 0. For the cosine of 3 theta to equal 0, we have the solutions 0 and 2 pi. So we have 0. And then 2 pi is all the way around the circle, so we're just going to put it, we're going to go in order, so that's going to be towards the end. And then we have pi over 6 and pi over 2. So pi over 6 and pi over 2. So these are all the solutions to the problem that we were trying to solve.